Good morning, my name is Joyce. I'm the Robonaut Operations Lead here at the Robonaut Lab at Johnson Space Center. And I'm here today to talk a little bit about the Robonaut 2 project. This is a joint venture between NASA and General Motors with the common goal of building a humanoid robot that can work safely with people and actually use the same tools that humans use. To accomplish that, we've built in a lot of safeties into this robot. This is our A unit. We have a very complex naming system for our robots. This is the A unit. We also have a B unit, which we'll talk about a little bit later. And behind me there's a C unit, which is our exact replica of the one that's on the space station. So we actually have 3 degrees of freedom in the neck, and this robot has 4 eyes or cameras, 2 standard cameras and 2 high-definition cameras that are used for the vision processing. It's a little different, doesn't think with its heads. All the processors are actually in the belly. These are where the computers and the main processors are stored, and they communicate with all of the joints on the robot as it moves. One of the key things and common goals between NASA and General Motors was to develop a robot that is safe to work side by side with a human. So the way this robot runs is it drives its joints based on torque values, and it knows the torque that it needs to drive the joint to a set position. We also have a torque limit, and what you can see here is it's hitting that torque limit and passing it. So it's sort of like somebody bumping into you. It's got the same thing, same feel to it, and you can tell that it's very flexible. I can move it around, and it's really waiting for me to get out of the way, and it will then continue its motion. And that's what makes it safe to work next to a human. Now we also have additional sensors. We have 6 degrees of freedom force sensors, 1 in each forearm, 1 in each shoulder, and those will measure what we call jerk forces. So a sudden impact, if it's moving fast and hits something, or if it's just doing something you don't like, you can kind of give it a quick jerk and it will safe itself and shut the motors off. One of the other main advancements for Robonaut 2, as opposed to its predecessor Robonaut 1, is the dexterity in the hands. So what we're going to show you here is a quick demo of its range of motion with its arms, as well as the dexterity in its fingers. This is very important because the more dexterity you have in the hands, the more human-like it is. So we can actually use the same tools that humans use, or astronauts if we're up in space. So as you can see, it's got the ability to close all of its fingers individually, and we'll also show that it can touch the fingers and the thumb together. So this dexterity in the hands allows us to assist astronauts or people on the ground using the same tools. If you've ever asked somebody to hold a tool for you, sometimes they can complain a little bit. The great thing about Robonaut is it will hold that tool for as long as you want without really complaining, but maybe a little bit. The other thing you may have noticed is Robonaut does not have legs yet, and actually we are designing and building those legs right here in this lab, and we hope to launch them to the space station next summer in the July time frame. And the astronauts on board will attach those to the upper torso, and after we do a lot of checkouts, make sure everything's working properly and the safety systems are there and working, we'll actually be moving around inside the space station. And this will be our kind of checkout phase, and we're going to take everything that we learn from moving around inside the space station and apply it to when we go outside the space station and walk around the outside, with the ultimate goal of helping the astronauts when they're performing spacewalks. So we can perform some of the tasks and help offload them while they perform more important tasks.